Okay, let's look at this very nice system of quadratic equations. The quadratic function to the top here is represented by our parabola, and the linear function represented by the line down here. And again, we see that both have been solved for y. That means we can take this part, which is equal to y, and set it equal to the other equation, because both expressions with x are equal to y. That way we get x squared plus 3x plus 2 is equal to 2x plus 3. Moving the 2x to the other side as well as the 3, we get x squared plus x minus 1 is equal to 0. Let's look at this trinomial, and we realize it cannot be factored because there are no factors of -1 that also add up to +1, which leaves us with our two other algebraic methods we've discussed. Completing the square would lead us to fractions here. Maybe we want to avoid that at this point, so I'm going to go ahead and use the quadratic formula. The quadratic formula, just as a reminder, is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in my numbers, I get -1 here, b is 1, plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is -1, all over +2. Go ahead and solve this. And our x is going to be -1 plus or minus the square root of 1 plus 4, in other words 5, all over 2. And remember, these are actually two solutions. We got -1 plus the square root of 5 all over 2, and we got -1 minus the square root of 5 all over 2. But we cannot simplify it any more than this. So this is the value that we also need to use now to plug into one of the equations to get our y value, the y coordinate of our solution. This is where it gets a little messy, but we're going to have to go ahead and do it anyway. So let's just start. I'm going to use the bottom equation to plug our x's in. That's going to make our lives easier. So we get 2 times -1 plus the square root of 5 over 2 plus 3. Fortunately, these two eliminate each other, and we have y is equal to -1 plus the square root of 5 plus 3. In other words, y is equal to 2 plus the square root of 5. This is one of our solutions. And the other solution, y is equal to 2 times -1 minus the square root of 5 all over 2 plus 3. Again, 2's cancel each other out. We got -1 minus the square root of 5 plus 3. Y is equal to 2 minus the square root of 5. So our first solution up here has the coordinates -1 plus the square root of 5 all over 2 and 2 plus the square root of 5. And Looking at those values, we're not entirely sure if the x is going to end up being a positive or a negative number, but we certainly know that the y is a positive number, so that has got to be this point up here. And our second solution is -1 minus the square root of 5 all over 2, and we got 2 minus the square root of 5. And again, along similar thoughts as before, we know that this time the x-coordinate has to be the -1, so this has got to be our point. And guess what? It is. All right, so let's move on to our next example. Here we have our nice linear function represented by the blue line. The other equation represents a circle. X squared plus y squared is equal to 17. You will learn more about those in pre-calc. And this time we have to go ahead and take this expression, which is equal to y, and plug it into the bottom equation for y. And then in that bottom equation, it's going to get squared. So we get x squared plus the quantity of negative x minus 3 squared is equal to 17. Just as we did in a previous example, I'm going to go ahead and expand that squared binomial and multiply it out using our FOIL method. We get x squared plus x squared plus 3x plus 3x plus 9 is equal to 17. Again, combining like terms, we end up with 2x squared plus 6x plus 9 is equal to 17. Subtracting 17 from both sides of the equation, we now have 2x squared plus 6x minus 8 is equal to 0. Ha! And what do we see? We have a greatest common factor, which leaves us with 2 times the quantity of x squared plus 3x minus 4 is equal to 0. Looking at our trinomial inside of the parentheses, we find that the numbers p and q that we're looking for are +4 and -1. Therefore, our factors are x plus 4 and x minus 1, which means our solutions are x is equal to -4 or x is equal to +1. Always remember, we have to flip the sign to get the solutions. All right then, let's find our y-coordinates. If we plug in -4 for x into our top equation, we get y is equal to the negative of -4 minus 3. In other words, y is equal to 4 minus 3. That means y is equal to 1, leaving us with the coordinates -4 for x and 1 for y. And that is this point up here. And our second solution we'll find if we take 1 and plug it into the same equation. And actually, again, it could be either one, but we want to get the least work for us here. We got y is equal to -1 minus 3. In other words, y is equal to -4. And funnily enough, now we have a solution with both coordinates switched. X is +1, y is -4, and that would be this point here. That looks very good. So far for using substitution as a method to algebraically solve quadratic systems. Now we're going to look at how can we solve a system by elimination. The cases where you solve a system of quadratic equations by elimination are rather seldom, and it only works if we look at our two equations and we are able to cancel out one of the variables, but that means both the linear and the quadratic term out of our final equation. It doesn't always work. So if we look at this system of equations, we see that the top equation has a positive y squared term in it, the bottom equation a negative y squared term. So if we add both equations, that should do the trick. So this way we're going to get 10x squared, no more y squareds, plus 90x plus 200 is equal to 0. And again, here we have a greatest common factor of 10, leaving us in parentheses with x squared plus 9x plus 20 is equal to 0. X squared plus 9x plus 20 is what we want to factor if possible. And if we look at it, we see that we do indeed have two factors of 20 that add up to 9. The numbers are 4 and 5. So we get 10x plus 4 times x plus 5 is equal to 0, leaving us with our solutions. X is negative 4, x is negative 5. Changing the signs. Remember, that's always the case, always necessary. So I'm going to take negative 4, plug it into our bottom equation, and I get in parentheses negative 4 squared minus y squared minus 16 is equal to 0. 16 minus y squared minus 16 is equal to 0. The two 16s cancel each other out. Y squared is equal to 0. And if y squared is equal to 0, then y is equal to 0, leaving us with our first solution, negative 4 and 0. And now we're going to plug negative 5 into that same equation for x. Negative 5 squared minus y squared minus 16 is equal to 0. 25 minus y squared minus 16 is equal to 0. 9 minus y squared is equal to 0. That means that y squared is equal to 9, or 9 is equal to y squared. Now we need to take the square root on both sides. Positive or negative 3 are equal to y. This means we actually have two y coordinates and two solutions with the coordinates negative 5 and 3. And also negative 5 and negative 3. In other words, a total of 3 solutions for this quadratic system. All right, you guys, that's it for today, and I will see you in class.